My name is Brian Likasar. I go by Liko. I'm the Global Director of Solution Architecture here at StormForge. Likasar. I'll be presenting a section on how StormForge right-sizes Kubernetes applications and optimizes resources at any scale, leveraging machine learning. What if you could ensure your apps are always right-sized while still meeting your SLAs and SLOs without manual tuning so that DevOps and SRE teams can focus on their efforts of innovating and automating and canceling out technical debt? So I'm Liko. I'm one of the Kubernetes nerds here at StormForge. And I've been in Kubernetes from before it was called Kubernetes, involved in that community and also in the open source community a lot longer ago than that. Spent a lot of time at Red Hat, for example. I'm based in Chicago, so it's a real pleasure to be out here in the Valley with all of you today. So the challenge that our customers tell us they face is that Kubernetes resource management is complex. And we can blame Kubernetes a little bit for this because Kubernetes itself can be complex. People aren't used to a declarative approach to resources and applications. And also, I love the animation at the top of this slide, so try not to get mesmerized by it. I dare you. Anyway, so when we're looking at Kubernetes resource utilization, everyone automatically kind of by default gets 5 things that they can adjust. And these are around 2 facets for CPU, 2 facets for memory, and then the number of replicas. This is kind of what you get out of box, so to speak. Now, that doesn't mean people set these. To be fair, it doesn't mean people set them, but that's what we typically look at or what people typically see. However, what I'll posit to you is that there is a better way or something that's being ignored or overlooked. And that is in the bottom right-hand corner where we've called that application settings. Now, in this example, we've got Java-based application settings. Now, don't worry, you don't need to be a Java expert to understand what I'm about to refer to. Java's been around long enough, you've probably heard people groan or roll their eyes when they talk about some of the things I'm going to talk about. So the first one we call out here is heap size. Now, heap size is a memory allocation that's done in Java to allow it to do what it does. I remember when I first learned Java, the whole talk about, I was a C programmer at the time, if I remember right, and they were like, don't worry, memory reconciliation, garbage collection is all automatically handled for you, not to worry. I can assure you I was very worried because I did not see that. You fast forward 20 some odd years now, things are in a much happier and better place. But suffice to say, when application teams are first moving to containerized based applications, if they adjust their heap size or the garbage collection algorithm they're using or any of the other parameters that you can imagine, there's over 60 of them available to the runtime, they tend to adjust them once. They tend to, hey, this didn't work. I have to adjust this. It works. I'm never going to look back again. However, heap size will directly impact the memory that you need for your application. So by not going back and reinvestigating that, you don't have a real good opportunity to get this correct. When I say correct, it depends on your goals. Everyone's a little different here. And in fact, you could argue that these are kind of the pick, I'll give you 3, pick any 2 of the 3 sort of situations. It doesn't have to be that way. If we investigate and interrogate what's going on in the application, we can then better inform what we do resource-wise. And then obviously the intent of calling out container 1, container 2, container 3 with the ellipsis here is scale. So what we do in kind of one place, we're going to end up rinse repeating or cookie cuttering or however you want to talk it, stamping it out on a template many, many times. So basically you end up repeating your sins if you commit them. And so we want to be thoughtful about that. So because of this complexity, you've got these are the 3 choices I was alluding to. You can either try to accommodate the fact that you're going to have performance issues of some sort if you don't throw enough resource at it. So that's always over provisioning is the answer. To me, I'm getting deja vu, like when we first moved to VMs. I really, by the way, I've been doing this long enough that this just makes my fist clench, right? It's like, come on, people, we keep doing this. You've got that. You've got configuration time and effort. There's so much toil involved with this manual churn that no one wants to do it. It's not the fun part of their job. Like people don't jump out of bed in the morning and say, hey, you know what I'm going to do? I'm going to find that 48th setting on the JVM, and that's going to make the difference today. I haven't met anyone who said that anyway. So if you have, tweet at me, please. So this is kind of the challenge that our customers face and what led to us trying to come up with a solution to market. So with that, this is kind of what I just described in a sense. you've got your environment, you're observing what's happening, and if you don't observe it, you can't measure it, you can't really fix it. And then we have all sorts of folks who are looking at this with different mentalities and approaches. The architects, of course, are trying to see if this fit their vision for what they imagined as far as how this would be deployed. SREs are, it depends on their role, but they're generally like, I don't want to get paged yet again. Let me see what I can't do to help this team make their app more stable. And then FinOps is complaining because the cloud costs just keep rocketing higher and higher. So obviously this begets the 4 problems in the top right there. Stressful, and it's manual, and again, it's trial and error. What can we do? What can't we do? So at StormForge, we came up with 2 different facets to our optimized platform. We have Optimized Pro on the left and Optimized Live on the right. Now, what I was describing on the previous slide with the application settings is Optimized Pro. What Optimized Pro will do is it's based on running a performance test. These are the different technologies that we integrate with, including our own performance testing platform, for example. We'll run a performance test against the live application and then see how it performs, set a baseline. And then we will use machine learning to adjust the parameters of the application under test and then run that same test again and see how it reacts now. So common example of that would be throughput. Customer has a throughput test. They know that when they run this test, they perform 5,000 transactions. We've now adjusted some parameters. Maybe we set the heap size a little larger and the throughput goes up. Okay, that's maybe positive. The goal is to increase throughput. We continue to iterate on that. And the way that we decide on these things is how many parameters we're adjusting. So I gave the heap size as one example. I told you that Java has over 60. Typically, we'll see between 5 and 15 get evaluated. The challenge here tends to be that customers don't often know what parameters will influence their application's performance. They can make an educated guess, but I would also argue that's bias, right? That's like, you know what, this is going to make the difference. That's where, contrary to the debate that may rage about machine learning and the biases that it has inherently, that's where our machine learning doesn't really have that sort of bias. As long as you give, yes.
When I'm doing optimization for things, I mean, you can optimize it for throughput, you can optimize it for latency, you can optimize it for different metrics. Which ones is Optimized Pro optimizing for?
So the customer gets to set the goal as far as what to optimize for. These are typically 2 dimensions at the same time, which is part of what makes this exciting, because if I was optimizing, I'll use my throughput example again, if you don't mind. If I was optimizing for throughput, but that is just increasing my cost with it, am I gaining as much? Now, if I can find a way to increase my throughput while keeping my cost steady or somehow even getting it lower, that is a big win. So that's typically what we see is cost ends up being a dimension. Now, when I say cost, it doesn't necessarily have to be dollar and cents.
So besides performance metrics, you're also getting cost information as far as how much it costs to run that and that sort of thing?
Yes, the way we do it is not the way you might expect. So it's not a dollars and cents thing necessarily, because everyone has different contracts with different providers. It's too hard to figure that out, and that's not the space we want to be in. It's more of what I would call a consistent ratio. So if you say that my baseline costs me, let's say 20, it doesn't even have to be dollars, it doesn't matter what it is. The other tests that are run will look at the CPU and memory, for example, that are used, use those as a fraction of that 20 to determine that this one was only 18, this other one might have been 22. That's how we determine.
Okay. And you mentioned it's prod versus non-prod.
Yeah, on this slide, where I'm going with that is people don't tend to run load tests in production. I said that all year this year, and I've run into 2 who actually do it in prod. Some of them do it overnight, and I say, wow, you don't like your people. But other ones, actually, that's their mantra, that's their mentality, is they do everything in prod. Prod is the only. I can respect and understand that, because you could argue also that we spend as much money, if not more, in the non-prod environments than we do in prod. That's why we say that, though. That's where our envisage comes from. I think the other element here, and I'll get to Optimize Live in a moment, is that we determine what we're going to do as far as setting specific applications in non-prod, and then we keep an eye on it in prod with Optimize Live, which I'll talk about in a second.
One would posit that because you're in non-prods, the adjacent applications and infrastructure will not behave like prod, so an experiment would be invalid because it's actually not being put in. I know it's a tough problem to solve. I spent the last 8 years solving it, so I'm going to reserve my questions so I don't sound like I'm being competitive. But yeah, And as Charity Major says, we all test in production.
Yeah. Or I used to say the real test is production, right? Like that's, throw the rest of it out. It doesn't matter as much. Yeah. Yeah. And I think this is more just to set people at ease, because I think a lot of folks, like most of the customers we speak with, are not what I would call cloud native. They had brick and mortar environments. They own their own data centers. They slowly but surely moved into more modern approaches. And for them, like the phrases change control still come up. The phrase, like all these other things that, frankly, I thought had left IT a while ago are still around. And again, it's because of the heritage that you bring with you. And no disrespect to that, but that's part of the challenge. So I think this is more about setting folks at ease than it is about explicitly telling you what to do with your environment. Far be it from me. Like, I don't know your world right now as a customer, right?
Explain the differentiation between experimentation and observation based.
Happy to. So experimentation based is what I've been describing as far as running a load test to determine the outcome, the results. And when I work with customers on this, a lot of what I get to do, which is a lot of fun, is help them set up performance tests that they feel comfortable with. What I mean by that is representing prod or et cetera. Right, yeah. Exactly. When we talk about observation based, this is using observability platforms like those outlined on the far right-hand side, most popular, which is Prometheus, to see what it's actually doing now that it's been deployed to prod, or now that these have been applied from Pro, for example. But the other element here that I would talk about is that this is kind of a virtuous cycle you need to keep going. And in that sense, what often happens is not too many people are comfortable with their load tests. They're not comfortable that they know that when they adjust this parameter, what that really did. I mean, they can see the results, sure, but they're like, well, I don't know why that happened. I don't know that, or my load test is inconsistent, or a lot of reasons, or frankly, they've never taken the time. So if you look across a landscape at a customer, instead of just an application in isolation, going based on observability is far more scalable and easy than going in isolation, looking into each application. It puts the responsibility in a different place. The people who tend to care about this most tend to be what I'll call a cluster owner. Cluster owners don't, try not to anyway, dive into the minutia of a given application. They know their troublesome applications maybe, or the most important applications, but they don't dive into that minutia. They'd rather have maybe a cluster view, the whole Kubernetes cluster in its entirety. And with that in mind, what they would then do is say, okay, you know what? I remember back when you first started developing your container-based app, you didn't know what you didn't know. So we gave you an option. We said small, medium, or large. Remember a good old t-shirt sizing? It's still around. And you chose a large because who asks for the small? And no one ever came back and asked you, was that the right size? And you never came back and told me, gosh, I only needed a medium. And so Optimize Live, what that's doing is using observability platforms like our partner Datadog. I think you all saw that announcement recently. Using those platforms to see what's actually being used versus what was asked to be used, and comparing the two, and then automatically applying the difference. Now, I would like for you to ignore the environment suggestion at the bottom for a moment, because funny story I'll tell you is that when we launched this far earlier this year, I think it was actually coincidentally around the previous Cloud Field Day, we thought prod was where more people were going to be interested in using this. And where I've seen the most interest, frankly, is what I'll call the sandbox environments, where everyone is playing for the first time with their container-based apps, and they don't really know how they're going to behave. And it's really the Wild West. No one knows what's going to happen. You're going to have noisy neighbors and all these other fun things. But again, everyone asks for the large. No one ever goes back and right sizes. No one ever gets that right. And so they've been using that to, what I would say, squeeze more juice out of the fruit, because that way they're able to get more people onboarded. Like, people are still on their journeys. You know this. You all work in the industry. You understand. This way they can use that environment instead of having to keep expanding that environment, because that's what they don't want to see. They're already facing that kind of double cost idea where I've got my existing, I'm working to go to a containerized base before I go to my ultimate destination. They don't want to pay that the whole time. So if we can get more efficiency out of that environment, it's super advantageous.
How do you gather app metrics in absence of an observability platform that you partner with?
So on the Optimize Live side, if it's not someone we partner with, we have no path to that. And that's basically, we're taking customer feedback on that, because this tends to hit, I'd say, even more than the 80% mark. So we haven't really had too many challenges in that regard. On the Optimize Pro side, we have a lot more flexibility there, because it is based on those performance tests that are run. Worst case scenario, what I've helped some customers do is end up scraping log files at the end. I absolutely hate doing that, but it is something that we can do as well.
Are you like, so you're not using like eBPF to pull up process information and sort of like pull anything back? At this point, they generally will have APM as your observation then?
Generally speaking, everyone has that. I mean, in Kubernetes, Prometheus is almost like I'm surprised it's not somehow already rolled into the greater community at this point, because it's almost always there. It's hard to find an environment where it's not. So that's the easiest path, if you will, for both. But on the pro side, we could do eBPF if that's the best way for that customer. No problem, as long as they can help us surface it. Because a lot of times what I find is that you have so many teams that end up having to get involved with the different layers of abstraction Kubernetes presents that it's like, oh, you know what, we're not gonna be able to get the node level metrics because excuse X. And usually it's siloing problem is still around too. All right, I think I verbally talked through this to visualize it a little better for Optimize Pro. Think of this in the middle as a controller or kind of the orchestrator of elements. And the Optimize Pro controller is going to run that load test. So on the previous slide, we had the different things we've integrated with before. It will run that load test against the system under test. We'll capture those metrics. Again, any of them are fair game for Optimize Pro. It will then collect those. It will send those to our backend where the machine learning is performed on those parameters to say, yes, these two parameters have influenced that. Sorry, I personify machine learning all the time. It's the easiest way to talk about it. At that point, it then informs Optimize Pro to tell this container or this whole deployment to restart with the new parameters and then run another load test. And we'll iterate on that in this kind of cycle at the top here as many times as specified. Typically, it's between 10 and 20 times per parameter that's being evaluated. And then finally, what will come out of that is what the machine learning refers to as its optimal config. I'll show you what that is in a moment. Now, these get expressed as a manifest for Kubernetes or a patch that can be applied to the running application.
So Brian, when
Yes,
you say small, medium, and large, you're talking about container size? Is that container instances?
Depending on the organization, how they've done it. Short answer is yes. Depending on how the organization has done their limits and their kind of, I'll call them quotas, that's usually what I'm referring to is you would ask that group, hey, what do you think you need? And they'd say, we don't know. And they say, okay, here's small, medium, large. Small is 4 by 16, medium is 8 by 32, et cetera. That's typically what it is. And it's basically like some sort of fence around what they need to let them go run on their own. Because a lot of this also involves, this is a little cultural, but democratization of it. So let them go do it themselves instead of forcing them to do it the way that they've done it before, break them from it. Okay, so this gets expressed as that manifest or that patch that can then be pulled into a CI/CD pipeline, for example, and then applied to another environment. For some folks, that even means prod. Most often what I see customers doing is they'll take the config files that are dropped as the optimal config, and they'll use that as part of the pipeline as success criteria. And so in other words, let's say you have a new release and you don't want that release to affect your performance by any more than 5%, either direction, positive or negative. They would include Opt Pro in that with that load test they're comfortable with to see that it has not caused a regression of some sort or an unexpected difference in performance before rolling it through. So that's another kind of idea that I've seen in the field.
Just to ask.
So this is really interesting, and I really like the idea of resource management for workloads within Kubernetes, because it's very difficult to say, okay, we'll set resource best practice, set resource work, limits on what you're going to actually deploy. Great. I have no idea what it's going to do or how it's going to react.
Right.
So when you're building the application, how the heck are you going to do that, right? So this is perfectly targeted. I love what I'm seeing. Can it work also with Cluster API for like a supervisor cluster solution where you could also deploy clusters in that area?
I would say a qualified yes. We'd have to get in the minutia, so we could probably table that for later. But I worked with a customer or a prospect, I should say, who was actually trying to optimize Kubernetes itself.
Yes.
And we did that. We accomplished that. It was kind of more of a proof of concept, though, because that's my world and where I live. I don't know where they've taken it since. That's the part I'd have to follow up on and find out. But it was demonstrating the results at a much faster clip, because this is all automated, than they were doing manually, which was the part that kind of blew their mind. I was a little disappointed because to me, it's like, okay, the machine learning helped you find the optimal parameters faster. Because if you think about it, every parameter, let's say you give it a range of 1 to 1,000, you now have to multiply those across all the parameters you're testing at once. So you easily get into the billions, if not trillions of combinations and permutations. The best answer, you could make the kind of, again, biased argument, it's going to be one of the extremes. Going towards 1,000 is better than going towards 1 or vice versa. But when you have those parameters, kind of, again, the combination of those, statistically speaking, you need to get there faster. If we were to let this run for years, we'd probably have the right answer. But we don't have time for that. Business doesn't have time for that. So what the machine learning is doing is honing in on that more quickly. That's the advantage, or what we bring to the table for that part. So that's why with this one example I'm giving, my heart breaks a little because I'm like, you're more excited about the automation because they had been running it manually. So I was like, come on, the machine learning was doing the cool stuff, not the, anyway, I guess it all comes together.
No, I think that's good, because at the end of the day, what this is doing, and probably we might get a little wrapped around the axle on the idea of small, medium, large, and in workloads, right?
Yeah.
That's difficult to kind of, think about, but that's great for what the modern operations guy thinks about when he's thinking about, okay, well, I have this application, it needs to run on this virtual machine, and that virtual machine needs this much resources.
Yeah.
When we get into the application side of things, especially in Kubernetes, now the operator has to actually, well, number one, know Kubernetes and know how to create resource limits on an application, because he's probably going to dictate to the developer, hey, your application is taking up too much resources. And then they're going to come back and say, well, I need those resources. And now you have that fun conversation that DevOps was trying to solve all along.
Right.
And so this is where I think this is perfectly targeted. So I'm soapboxing a little bit, but my question is, when does that idea of t-shirt sizing exist in StormForge, where the operations guy can say small, medium, large?
No, we don't have any notion of that. I think, to be clear, when I talk about t-shirt sizing, instead of thinking of it as the resource amounts as well, think of it as the kind of starting point that an organization's, maybe SMEs or whomever, give to a team who's finally starting on this journey. So it's like, here's where you're starting from. Go. And they, that's the guidance they're given. At best, they have an internal wiki that's like, hey, when you run into this, change that. But again, it's one parameter, doesn't apply universally. Like if you have a Java app versus a Python app versus a Golang app, I mean, it gets really funny to see.
Well, especially because the metrics have changed. We're no longer in 4x16. It's I need 1,422 millicores,
right?
And
right.
I need 422 megabytes of RAM.
Yep.
Like, we're not talking gigabytes anymore. So the granularity of it is so fine, and it's the advantage because you can pack all this stuff together. But if you have an application that has 3 containers in a pod, and it's meant do you scale out or do you scale up?
The eternal question, really, too, right?
Right,
Yeah.
and then at that point, once you reach the limits of what's capable, then at what point do you then make a decision where you actually need to scale the underlying infrastructure?
Right.
Again, a little close to home. I've spent a lot of years talking about this problem, but it is an interesting thing in that, the t-shirts are. And
I'll no, you're setting me up for something else I'll talk about in just a second as well. Remind me if I don't say something about.
Oh, don't worry, I will.
About the underlying infrastructure piece, because we're playing at a higher level, right? Like, we're not the cluster autoscaler. We don't mean to touch infra necessarily. That's up to the customer and how they do it. So final point on Optimize Pro. This is a what I'll call a facsimile of a live environment, because this displays a lot better as far as font sizes go for presentation purposes. But in this example, we've got latency versus cost. So the application under test was trying to get the latency as low as possible. The blue square is the baseline of the current config. So where we started, you run the test, you see what it did, and you're like, okay, this is what I'm comfortable with and what I'm used to. Now we're going to have StormForge Optimize Pro evaluate, let's say, 5 parameters hypothetically, and see how it impacts latency and cost. Now, the ideal will be somewhere in the bottom left, right? The lowest latency, lowest cost. What Optimize Pro and machine learning has done here is it has a recommended one. Now, this frankly is just the median value of all the different ones that it has outlined as potential optimals. It doesn't necessarily have your SLOs or SLAs in mind. So in that case, this is where humans, again, still have to be involved in the same way the human created the experiment to know what we're evaluating. The human can also then go, what is most important to me is the absolute lowest latency. So I'll go maybe here instead. Now, that didn't really do a heck of a lot for me cost-wise, but gosh, it got my latency way down, so I really like that. And vice versa, of course. Like, latency went higher, but I'm okay because my cost went so significantly to the left. Now, obviously, we don't even have the scale on this graph, so I can't give you those details, but That's the sort of thing that happens. So if you were to take what I'll call like the default optimal configuration, this is the one you get. It's in the middle of all of them, the median of those. Otherwise, you can choose explicitly. I want the lowest cost one. I want the lowest latency one. It's up to you. Okay, so we spoke about observability earlier and optimize live. And if I can touch on that again and go a little deeper on it. In this case, so to contrast that with before where we had the controller in the center doing this, a couple things I'll call out. First thing is that Optimize Live runs against the Kubernetes API. Again, ignore the environment name here. It doesn't necessarily matter. Like I said, sandbox environments have been very popular too. It runs against that direct environment based on the observability metrics, what you're using versus what you're asking for, and applies those. And the default out-of-box experience is automatic approval. Now, I already know what you're thinking. You're like, wait a minute, Lico, you just told me that I'm going to automatically apply things directly to Kube API. There's no change control. There's no approval in the process. And the answer is yes. That's what I'm telling you. And that makes a lot of people nervous as heck. And that makes some customers who I've spoken with, they were like, this is exactly what I wanted. Now, I will be very candid with you. I was surprised to hear that, especially from this customer because they're a financial institution. And when I talked to them, it made a lot more sense to me. They have so many clusters and they have so much waste and they know they have the waste, but they have not really been able to quantify it. Maybe they've used tools that help them surface it, but they don't know what their waste is. They're like, we don't have time for this. I would rather have this go and apply it all the way, maybe even deal with an alert ticket or two when an app is impacted, than continue to waste all the money we're wasting. And I was quite surprised. Now, in most of my proofs of concept, I right away set that into manual mode, and we'll show you later in the demo what we do there, so we can see what it would do. This gives comfort to the customer. Yes, it's doing the right thing here. The machine learning is looking at the metrics and taking into account your risk tolerance, which is another element of this, to say, you know what, I'm okay being aggressive with CPU, because the worst case scenario is I'll have some throttling of my application. But if I get aggressive with memory, you'll get an out of memory error, which will crash out the application and get it into a restart loop, which nobody wants. That's everybody's like eye roll moment of Kubernetes. So here, observability, like we've, with our announcement with Datadog, all of that in one pane of glass to look at to see what it's doing, what the recommendations are, and then automatically applying or going in manual mode. And this now part of what we're announcing is the HPA target utilization. So one of the frequently asked questions that every customer has when we talk about Optimize Live is they say, okay, that's great, but what about when the spike happens? So let's say we're doing this in prod as you have on your slide, which, man, I really got to remove prod from that. What happens? I'm like, well, what do you do without us? Like, what happens? And they're like, well, we have the horizontal pod autoscaler, which knows that the load is increased, it sees the utilization go up, and it adds more replicas. I was like, fantastic. How do you know when to scale? And they're like, well, we just set it to 60% utilization. I was like, well, what was that based on? Now, of course, my angle here is you should use Optimize Pro to do an experiment to find out what the best one is. We don't have time for that, or we're coming up on the retail busy season, if you will. We can't do these things. What we're now doing is using the same machine learning we've been using before to watch that as well and give them a scale point. So we're saying, hey, 60% wasn't the right answer for you. 80% is much better, cuts out the waste, only scales when it needs to. So that's our exciting announcement for today. We're real excited about it. Yeah, I think that's everything.
What's the baseline for the metrics? I mean, you're taking metrics from the time this thing's deployed until forever, as long as you're operational, or is it like over the course of a month or something?
We look back the last 2 weeks.
So how can you tell that the HPA target utilization might be okay at 80% versus 60% if you haven't seen their peak worst case scenario sometime in Amazon day or something?
Sure, right. So the way that we feel confident about that is the 2 weeks finds the day of week seasonality, if you will, or the time of day seasonality. It doesn't catch, so the hypothetical, right? I'm in the middle of the month. I don't catch my month ends. Uh-oh, like what do we do there? That's where the HPA saves itself, so to speak, even if we're wrong, okay? Freely admit we could be wrong. Even if a recommendation is poor, the HPA will cover you for that because it will keep scaling out replicas. So even if we're doing it maybe at a higher point, like in other words, before you would normally do that, it's still going to keep doing that scale. So we're still covered in that regard. But prior to this release, we didn't consider that. And so all people were getting was right-sized containers, which could then be stamped out way too fast, inefficient the whole way. And in the demo later, you'll see like memory waste is one of my favorite things to point out because so many things tend to be bound one way or the other. You'll see where that can add up quite quickly.
You also catch things like, further down to the node layer. So if you get a whole bunch of kills that are firing up, and then you realize that in the live that you're like, okay, there's actually a memory misconfiguration that is affecting the node itself. That's causing it to actually terminate all these containers.
We don't, and part of our hesitancy there to dip our toe even in that water is other people do it better, and that's not the space we necessarily want to be in.
Good answer.
Yeah, yeah. I mean, we flirt with this all the time, to be candid. Like Yasmin and I've had plenty of conversations where we're like, "Oh, it'd be really cool if we did this," and it's like, "Oh, wait a minute, where are you going?" It's like Datadog's really good at that. Why are we going there? Okay, yeah, fair. Let them do that. You reminded me too, Eric, that we want to talk a bit here. The challenge of a lot of people will talk to me and they'll be like, "Well, hey, we've got cluster autoscaler for our nodes. We don't need a solution like Optimize Live." And I was like, here's the thing that you forgot about a declarative system like Kubernetes. If you tell Kubernetes, I need 2 CPU, 4 gig of memory, it will always give you that. Even if you're wrong, even if you use a 1 millicore, 1 meg, it'll give you what you asked for every time, full stop. So you can have all sorts of neat technology at the node layer that's scaling up, scaling down, consolidating, collapsing, whatever it is. It doesn't matter. If you're telling it the wrong thing, it's going to provide you the wrong thing still. So I think some people get confused about that from an infra perspective a lot.
So StormForge has the visibility into what production load and looks like through the observability, and then it's going and doing the testing in the lab environment. So is StormForge doing a middle layer of being able to say, this is how much we see like data throughput wise in production, and then scale or do better estimates in the lab environment for what that would look like to scale? Or can it increase artificially the workload type in the lab to make it match and be more, because that's the problem that we all have is labs are great when you're allowed, well, everybody has a lab, not everybody has production.
Right.
But you have your production environment and it's running at 120%. The challenge is having that lab environment either meet that level in short bursts or to be able to do better estimation. Does it do anything in that account?
I think where we're headed, I don't want to speak too forward looking, especially with the estimate of the room who controls it all. That's something we've been kind of, I'll call it a vision statement. That's where we want to get, is to where these can inform one another.
Okay.
We're not there yet, but I think that's the road we're on. Like, I think that's our ultimate vision where we want to go.
Okay, cool. Thank you.
Yeah. Okay, so the net result of now including the HPA scalability recommendations is, instead of something like this, here's the actual usage, and this is an example of CPU. Here's what they asked for. They asked for 5 full. The peak it ever got to was somewhere around like 2.8. So this gap here is all wasted resource. Now remember, this is probably the view of one deployment. Kubernetes is all about scale, tens of thousands, hundreds of thousands potentially. Here's what we're doing. We got the actual usage. This line here is our recommendations and the replica count of where we think they should be. So again, this is a mock-up, not the actual. I'll show you the live demo in a bit. Following closely to where the actual usage is. And this was all predictive. So in other words, we may have seen this spike and spiked up to here. So again, because it's a facsimile, I'm trying to give you a real world. We probably saw this spike and jumped up to here and stayed up there above that peak. And then when we saw it start coming down, that's when machine learning would suggest coming down. So we try to hug that as tight as we can. That also goes back to something I mentioned earlier about risk tolerance. Customers have the option of low, medium, and high risk tolerance. In other words, how tightly we're going to go against what we believe to be the correct answer. We are freely admitting we may not be correct. So what's your tolerance for that? And what I always tell customers is, when it comes to memory, go with low risk tolerance, because if you kill stuff, it's tough. CPU wise, you can perhaps be a little more aggressive. So finally, kind of in summary, the key attributes of machine learning driven optimization. A big thing that we like to talk about is turning observability into actionability. We have all this data, we've been capturing metrics, hopefully, right, of all these things, but we haven't done anything with them. And so that's, like I said, that customer who is doing this in automatic mode really wanted. They wanted to be able to do this at scale quite quickly. And so that was a big part of that. Leveraging machine learning, this has been in the works for 6 years. We've been working on it. It's not brand new. We didn't just add machine learning to our product and say that's what we do. It's what it's been our founding principle. Our data science team, those with doctorates in data science have been working on this for years. And it's easily automated and scalable. And that's the key to me as I talk to some of these really large companies who have tens of thousands of nodes comprising their Kubernetes environments. Like, we can't onesie-twosie any of this. They're like, that op pro thing is neat, but I'll leave that to an application team. I'm more worried about the landscape. All right, and to learn more, please visit us at stormforge.io.